Hi, Assalamualaikum. My name is Amir Shahira binti Ruzaimi. My metric number is AF.90081. Today I will present for introduction. Geotechnical engineering is a subdiscipline of civil engineering where the use of earth material, which is soil and rock, is to improve and defend social and life. Geotechnical engineering relates to soil, which is soil is the outermost solid layer of the earth. Solid are unusual engineering material compared to material that described in structural mechanics. It is because solid are the natural material formed by the weathering of rock by the action of climate and living organism, and the behavior of soil is the legacy of natural process from the origin to the actual state. This is make the soil character in a homogeneity, isotropy, and basic parameters such as strength, stiffness, and hydraulic conductivity that need to be measured. Other than for engineering, it also capable to supporting plant growth. There are two main cases of soil, which is organic and mineral soils. Organic soil come from living materials such as plant and animal remain, while mineral soil come from rock and others non-living material. Soil is important to human for shelter, then human use soil for gardening and so on. But soil also have their own problem, which is we call soil failure. In civil engineering, which is geotechnical subdiscipline, there are many problems associated with soft soil in construction, especially pit soil, clay soil that causes problem to construction, which is a great problem due to undesirable engineering properties. Pit soil considered as an extreme form of soil very problematic, followed by clay soil, which is high moisture content, low yield stress, low strength and high compressibility, and low permeability, and consequent low quality for construction. So there is example of problematic soil that is not suitable for construction. Problematic soil make the construction foundation extremely difficult, which is include expensive soil, collapsing soil, and sanitary landfill. To deal with these slope stability issues, various approaches have been adopted and delivered over the years. The approaches now have been more of computation rather than the manual. Various software are available to analyze the slope that are liable to failure by calculating the factor of safety. Among the famous approaches are finite element and limit equilibrium method.
Assalamualaikum and hi, my name is Rose Ashira Atasha binti Adi. My metric number is AF19022 and I'm gonna explain about literature review. Slope stabilization methods. It has three methods, which is the first one is geometry techniques. It is to bring a change in the geometry of slope. The second one is hydrological techniques that lower the water content of soil or rock material by lessen the groundwater table. The third one is chemical and mechanical technique, which is to enlarge the shear strength of the critical plane or soil of rock or mass by external means. Additionally, the shear strength of the slope can also be increased by reduce the external forces that triggering the slope failure. Geometrical techniques. The first one is to flattening the slope. Number 2 is to remove part of the soil or rock. Number 3 is remove load from the top of the slope and hence reducing the shear stress on critical planes. Number 4 is constructing pressure berms at the top of the slope and whereby providing extra safety against toppling failure. Number 5 is renewal of slip material by free draining materials and hence reducing the build-up of pore water pressure. Number 6 is by recompaction of slip debris to allow more resistance against loading. Hydrological techniques. The first one is to installing surface and subsurface drain pipes and hence it's lessen pore water pressure. The second one is use inverted filters. The last one is use thermal techniques such as ground freezing and heating method. Chemical and mechanical techniques. The first one is by using grouting to enlarge the shear resistance of slope, build restraining structures such as concrete gravity or cantilever walls. The third one is construction of gabion structures, baby creep walls, and embankment piles in order to allow resistance against toppling. Number 4 is build lime and cement columns, put ground anchors, rock bolts, rock piles, and others to provide effective tension to rock blocks. And the last one is by planting shrubs and grasses to lessen soil erosion.
Next is technique of slope stability based on case given. Landslide occur in a variety of environments, characterized by either steep or gentle slope gradient or from mountain range to coastal cliff, in which case they are called submarine landslide. Gravity is the primary driving force for a landslide to occur, but there are other factors affecting the slope stability that produce specific conditions that make a slope prone to failure. The Journal of Analytical Study of the Cases of the Major Landslide of Bukit Antarabangsa in 2008 stated that the increased landslide to occur is closely related to development of infrastructure such as highway, road, and the new settlement area that are rapidly and urgently spreading to the hill. A massive landslide occurred in Bukit Antarabangsa has been reported. The landslide happened due to the residential that located on hilly terrain. Heavy rainfall would make it more possible for the landslide to occur in the area. In most landslide studies, the primary focus is toward the technical perspective of failure, and human error are neglected. Authorities have already established that no sign of earth motion were in the record. So the possibility that the 2008 Bukit Antarabangsa landslide was triggered by earthquake force is negligible. Another possibility which has been highlighted is that the landslide was the outcome of a pipe burst. The official authority of Majlis Pembandaran Ampang Jaya at Ulu Klang, Malaysia reported on the case identifying leaking water pipeline near Jalan Wangsa 11, which is very close to the landslide area. It is responsible for the build-up of water pressure in the soil pores. They observed that the landslide took place after 20 years of project development and is thought to have been the result of a water pipe to burst on the hill. For this type of slope failure, it is not obvious until the structure collapses. From the case study, the type of slope is a man-made slope due to the non-engineered field on the slope that developing the tension crept over the area. Thus, the soil crept over the years and damaging the system of active water pipe along the abandoned houses and make the pipe leak. Then, it contributes to continuous soil saturated at the lower slope. To solve this case, I recommended to cut down the unstable tree and construction the barrier at the toe of slope surface. Besides, they suggested to cover the surface slope by crest using the turfing method to prevent slope from erosion. Structural engineering provides us with many techniques for fixing the slope that we might fail. To ensure the slope stability, one common technique is to take soil core sample, determine the stratigraphic layout of the soil, and then cut breaches in the weaker soil. Then, the more stable and uniform soil type can be placed over top to promote the slope stabilization. Besides, digging out soft soil or replacing them with gravel that is less compressive is one way to prevent failure urban slope which trickle down to the slope stability below. Other solutions are like retaining wall, through soil compression, and drainage method to prevent saturated and seepage.
Hi, Assalamualaikum and good morning. My name is Siti Nurharishani binti Muhammad Salim. My metric number is AF190098 and today I'm going to present to you the techniques of slope stability based on the case given. For this case study, we're using grouting in cement concrete as the main technique because it is a process where fluids-like material that in suspension or a solution form are injected into the subsurface of the soil. It also helps improving the shear strength of the soil in the failure zone. The process is to freeze the excessive pressure to form root-like or skinny lens shape zone material within the soil mass. We have three types of growing method, which are hydrofracture growing, compaction growing, and the last one is jet growing. For hydrofracture growing, the growth will split open the ground using hydrofracturing, and it will create the lenses that would penetrate void spaces or fracture. For compaction growing, it is usually used to stabilize or to identify the existing weak soils. For jet growing, it is a process of creating soil concrete columns or jet growth columns in place with a stabilizing growth mix delivered under high pressure. Other techniques that also can be used for this case study are water drainage, sheet piles and retaining wall, slope flattening, and consolidation of surcharging. For water drainage, the drainage helps to reduce the seepage forces and helps to enhance the stability of the slope. For sheet pile and retaining wall, it provides lateral support and increase the stability. For slope flattening, it reduces the weight of the mass tending to slide or collapse. For consolidation of surcharging, it enhances the stability of slope in cohesive soils. So that's all for the technique of the case study. Thank you.
Hello and Assalamualaikum. My name is Muhammad Izzal bin Azmi. My metric number is AF190206. Today I would like to present about the application of any standard. For methods and techniques, our group used the method soil nailing. For the technique, we use the grounding and injection cement concrete mixtures. So commonly we use the norms of practice and design manual for design of soil nailing in Malaysia are British Standards BS 8006 1995 Code of Practice for Strengthened Reinforced Soil and Other Fields. So for the B, US Department of Transportation Federal Highway Administration FHWA 1998 Manual for Design and Construction Monitoring of Soil and Walls. However, this does not apply to all slopes. Therefore, phase failure is a critical failure that should not be disregarded. The following clauses in B, PS 8006 and the FHWA manual emphasize this. BS 8006 1995 clause 6.7.3. Facing should be designed to accommodate the loads resulting from horizontal soil pressure and the corresponding reinforcement tension reaction developed in the connection between the facing and the reinforcement. So for the FHWA's manual for design and construction monitoring of soil and walls, page 95, the facing structural design requires provision of adequate concrete thickness, reinforcement and moment capacity to resist the earth pressure applied to the facing span between adjacent nails, head, and provision of adequately sized bearing plates to provide adequate punching shear capacity. So that's all for me, and thank you.
Assalamualaikum. My name is Azaria Batrisha binti Muhammad Hamdin. My metric number is AF190148. Today I will talk about the long-term stability for the chosen technique, which is the growting of cement concrete. The injection of pumpable materials into a soil of rock formation to change its physical qualities is known as grouting in civil engineering. Grouting is suitable where soil permeability would place a high demand on pumping or where subsurface conditions would make drilling wells economically and efficient. Grout can also be used to build pile foundation, ground anchors, underpinning roads, dams, and other structures. Depending on the soil or rock type and the area to be grouted, several materials may be used for grouting. The essential procedure is the same. Fluid grout is injected into the soil or rock which settles and decreases or scales the material permeability. How long the grouting can sustain the slope stability? The stability of the slope depends on the material and other factors. There are numerous variables to consider when designing a long-lasting structure. Grout is a composite substance made up of water, cement, and sand in most cases. Filling gaps under machines or other structural elements, sealing joints, and opening in surfaces, and reinforcing existing structures are all common applications. When discussing about how long does the grouting can last, it includes the durability of concrete. A durable material helps the environment by conserving resources and reducing waste, and the environmental impacts of repair and replacement. The design service life of the most structures is normally 30 years, although building can endure 50 to 100 years or beyond. Most concrete and masonry structures are demolished owing to functional obsolescence rather than deterioration due to their endurance. A concrete shell or structure, on the other hand, can be repurposed if a building use or function changes, or if the interior is refurbished. Concrete has the ability to survive natural deterioration mechanism as well as natural disaster as a structural material and as the building's outside covering. Since the grouting of cement concrete has a lot of benefits such as excellent properties, adjustable consistency, good adhesion to concrete and fast strength development, it can survive until someone decides to knock them down. Concrete are known for their strength and longevity. To improve the slope stability, soil nailing is suitable for the remedial strategy. Soil nailing entails reinforcing and strengthening existing grounds by installing closely spaced steel bar known as nails into a slope as construction progresses from the top down. This procedure produces a strengthened portion that is both stable and capable of retaining the ground beneath it. Soil nailing has less impact on nearby properties, and it can be used for strengthening of either natural or man-made cut slope, as it can strengthen the stability of slope. It can also increase the longevity for the grout and the concrete, and it will become more secure and can sustain the stability of slope.
Assalamualaikum and hi, my name is Rus Ashira Atasha binti Adi. My metric number is AF19012 and I'm going to explain about conclusion. The first one is rocks that presents with soft, highly jointed, folded and faulted are highly eroded and easily erodible. Besides that, heavy inflow of surface and subsurface water from the uphill side to the landslide zone also can affect stability. We must improve the drainage system with new drains and culverts also can be proposed to redirect the flow of water from the landslide area. In another way, density tests and stability analysis of natural slopes of right and left part of landslide specify the loose condition and chance of erosion of slopes. To stabilize the same, gabion walls has to be proposed to supply the toe support and surface erosion that has been in charge of by laying of geogrids in the slopes. The last one is the correct channelization and direction of water flow away from the landslide also must be carried out.